Hey, you guys. Welcome back. Today we're going to go over the next part of the study guide. So, looking at this, we have word problems. Word problems are kind of tough because you have to read and try and figure out what kind of operation am I going to be doing? What am I going to be doing with the numbers that are involved? But they're really important because word problems come up in your everyday life, especially once you become an adult. So, we have to go over them now because they are important. So, look at this first one. It says Freddie wants to buy a new pair of Nike shoes that cost $60.50. He makes $5.50 per hour working at his job walking dogs. How many hours must Freddie work to buy the new pair of shoes? Let's see, he makes $5.50 an hour and he needs $60.50. So that's kind of tough to think about. But if you think $5.50 an hour, that'd be like $5.50 1 hour, about $11 for 2 hours, about $16 for 3 hours. It's going to take a good bit of hours to get up to that $60.50 mark. So we have $60.50. Let's see, we got $60. Let me write it over here, not there. There we go. We have $60.50. That's how much he needs. He makes $5.50. So we're going to divide that $60.50 by 550 because we're trying to split that up with that hourly rate he makes. We're trying to see how many times 550 goes into 6050 because that's going to tell us how many hours he has to work. So let's set it up. The first number always goes inside the box, 6050. I'll put the other number, the divisor, on the outside. Now, if we have a decimal right here, we have to turn it into a whole number. So looking at this, I'm going to move it twice to turn this into a whole number. 550. If I move that one twice, I got to move this one twice. So now let me write my new problem. 550. Actually, let me write it over here. Kind of ran out of room. Let me write it back over here. All right, we got 550 into 6,050. This is where my new decimal is right there. That's where I moved it. So 550 into 605. Well, I know that goes in there once. So 550 times 1. Notice how I put the 1 over the 5. I don't put it over the 6 or the 0. I put it over the 5. Okay, that's because I'm doing 605. That's what it goes into. It goes in there once. I get 550. When I subtract, I get 5. Can't do that, so I borrow. Sorry, 5. 10 minus 5 becomes 5. This is 0. I bring down the 0. Oh, look. Oops, that's an arrow. 550 into, this is hard to read, but it says 550. 550 into 550 goes once. Multiply. I subtract. I'm left with a 0, nothing left to bring down. He's got to work 11 hours to make $60.50. 11 hours. I'm going to give a little bit of that an erase so I can see, so I can see the next problem. Let's see, give this bit an erase. So look at the next problem. I have Brody bought 5 slices of pizza at the DeSanta basketball game. Each slice cost $1.35. How much did he spend in all? Every slice costs $1.35. He bought 5 slices. I'm going to multiply the cost of each slice by the number of slices he bought. So let's go through this. 5 times 5 gives me 25. Carry the 2. 5 times 3 is 15 plus 2, 17. Carry the 1. 5 times 1 is 5, plus 1 is 6. And I look at my problem to see how many decimals are in how many numbers go behind the decimal in my answer. So I got 1, 2 numbers behind a decimal in the problem. I want 1, 2 numbers behind the decimal in my answer. So how much did he spend in all? $6.75. Over here, Brody pays with a $20 bill. How much change will he get back? So he pays with a $20 bill. His total cost was $6.75. So I'm taking that 20 and subtracting $6.75 to see how much change he's going to get back. Now we put the $20 on top because that's the larger number. If you try to put the $6.75 on top, this won't work out for you as well. It won't work out at all. In fact, you have to have the larger number on top in order to subtract properly. So $20, $6.75. Notice how my decimals are lined up perfect. Let me give this an erase. There we go. I'm subtracting. So now, 0 minus 5 can't do. Can't borrow from here, can't borrow from here, can't borrow from here. I'm going to borrow from this 200. So now that's going to become 199. 10 minus 5 is 5. 9 minus 7 is 2. 9 minus 6 is 3. 1 minus 0 is just 1. 1325 is how much change he gets back. Now, what's tough about these problems is that it doesn't tell you exactly what operation to do. You have to try and think about it and try and figure out what operation would go best here. And sometimes you might do the wrong one. And if you do, that's okay. Give it an erase and try a different one. If your answer doesn't make sense, then you probably did the wrong operation. So looking at any of these problems, 11 hours sounds about right. That sounds pretty close to probably how much you would have to work to make $60.50. Every slice of pizza that Brody bought cost $1.35. If he bought 5 of them, yeah, that's about $6.75, somewhere around there. And if he paid with a $20 bill, you'd get around $13.25 back. If your answer doesn't make sense, you probably made a mistake or just chose the wrong operation. That happens all the time. It's easy to do. So try and make sure your answer makes sense before you circle it and move on. Okay? Let's look at the next one. Let me let's see, get back over here. We'll scroll down. There we go. The marker. Perfect. There we go. All right, so this question, let me give that an erase. All right. This one says 3 friends found 1/4 of the leftover pizza in the refrigerator. It's like that whole pizza was originally like this, but this much was already eaten of it. So left in the fridge was this much right here, just that 1/4, that one sliver. That's all that's left, all right? So 3 friends found 1/4 of a leftover pizza in the refrigerator. They wanted to share it equally. If they shared it equally, how much of the pizza would each friend get? So looking at this, I have 3 friends. Everyone's initial, actually, hang on one second. If they're splitting up the pizza, whatever's being split up always comes first. So 1/4 is what they're trying to split up. 3 friends found it. So a lot of kids want to do this 1/4 divided by 3. So if we do that, because we're splitting something up, let's see what it turns into. Whenever we divide fractions, I always use that keep, change, flip method. So looking at this, it would be 1/4. Keep it, division becomes multiplication, and the number, this one, becomes 1/3. That's because there is a 1 underneath this. So I'm going to flip it, and now the 1 is on top. So now I get 1 times 1 is 1. 4 times 3 is 12. And that is how much each friend would get of the original pizza. Let's look and see what if I multiplied 1/4, times 3 over 1. What if I multiply these two instead? I'd get 3 over 4. Is that how much each friend would get of the pizza? No, that doesn't make sense. They only found 1/4 of the pizza. They couldn't have 3/4. It doesn't even make sense. Again, it's one of those things where your answer has to make sense. And this one, what comes first in your division problem has to be the thing that's getting split up, okay? If I did it the other way, let me give this an erase and show you what the other way might look like. What if instead I had 3 divided by 1/4? I would use that keep, change, flip method because there's a 3 there's a 1 underneath the 3 right there. This would turn into 3 over 1 times 4 over 1. I would get 12 over 1. Wait, that would reduce down to 12. That's like saying there was 12 pizzas, or I don't even know what that means. That's crazy. That can't be right. So whatever's getting split has to come first. All right, the pizza's getting split up, so it comes first in your division problem. Again, hopefully you would maybe make some of these errors and see that doesn't make sense and you would try something else. Let's look at this next one. One painter finished painting 2/5 of a house and another painter finished painting 1/3 of a house. What's the difference in the two amounts the painters have finished? Whenever we're talking about that word difference, big key word right there, that means subtract. So look at this, I have 2/5. It says what's the difference? So I'm going to subtract 2/5 minus 1/3. Now let's see, this is just a subtraction problem. We always turn subtraction problems into addition problems using that keep, change method. So 2/5 plus negative 1/3. Now the denominators are not the same, but I need them to be. Remember, we can't add fractions until we have common denominators. So I'm going to find the lowest common multiple of 5 and 3, which is 15, yep. Let me rewrite these fractions now with common denominators. I turn 5 into 15 by multiplying it by 3. Do the same on the top. So now 6 over 15. I turn this 3 into 15 by multiplying it by 5. I'll do the same on the top. Negative 1 times 5 is negative 5. So this is my problem now. 6 over 15 plus negative 5 over 15. Do they have the same denominator? Yes. I'll keep that in my answer. Now just add the numerators. 6 plus negative 5 gives me 1. 1/15 is the difference in the two amounts that the painters finished. Let's look at the next one. Which expressions are equivalent to this expression? So, negative 4.6 minus 1.8. That's a subtraction problem, and I know whenever I have subtraction, I turn it into addition using that keep, change, change method. So this is really negative 4.6. I keep it the same. Subtraction becomes addition, and change the sign of the following number, negative 1.8. So let's see, any look like that? 4.6 minus 1.8? No, because look, they got rid of the sign in that 4.6. So that can't be right. This one, it looks like they turned subtraction into addition. They kept the first number, subtraction into addition, but they didn't change the sign of the second number. That can't be right. They didn't do it properly. This one, 4.6 plus negative 1.8, it looks like they changed the 4.6. It was a negative, now it's a positive. But we're supposed to keep the first number the exact same, so that can't be it. Negative 4.6 plus negative 1.8. Let's see. Keep, change, change. Oh, they did it. Perfect. That's it. Now, if I actually went and solved this, I know a negative 4.6 plus a negative 1.8. When I add two negatives, I keep a negative sign. So this is positive. That can't be it. This is negative 6.4. That's what I'm looking for. Let's look at the next one. Convert the following decimals into fractions and simplify if possible. So whenever we convert decimals into fractions, the biggest thing I have to look for is place value. So looking at this fraction 0.9, wherever the decimal part, wherever the number after the decimal ends, that's the place value. So this is 0.9. That 9 is in the 10th place. That means my fraction has a denominator of 10. And then I put this number right on top as the numerator. 0.9, 9/10. Doable, easy, right? We can do that. Let's look at the next one. This fraction, this decimal ends in there's the 10th place, there's the 100th place. So it ends in the 100th place, that's my denominator. And then I put this right as the numerator. Now the one thing some kids kind of forget about is that if it's a negative decimal, it has to be a negative fraction as well. So negative 11 over 100. This one right here, let's look at and see where place value the number ends in. 10th place for the 7, 100th place for the 5, so the denominator is out of 100. And then I put the number right up top, 75 over 100. Whatever's here, I put as the numerator. Now this could simplify down, and if you can simplify a fraction, you should. I could simplify this down by dividing both by 25. That's the GCF there. And I get 75 divided by 25 gives me 3. 100 divided by 25 gives me 4, so I get 3/4. 0.345, let's see, we got the 10th place, the 100th place, and then the 1000th place. That's how far that decimal extends to, so it's going to be out of 1,000 as the denominator. Then I put the number right by the decimal, this whole thing, I put it as the numerator, 345. Now, this one is kind of a large one, right? So we would have to simplify it. I could divide them both by 5, and honestly, we could simplify this down a pretty good bit. 345 divided by 5, let's see, that goes in there. You know what, honestly, you aren't going to have one just like that on the quiz. Let me see what that simplifies down to. Don't worry about those large numbers. 345 divided by 5, 69, 1,000 divided by 5 equals 200, and we can't simplify that one any further. Perfect. Oops. 69 over 200. All right. Oh my gosh, look at that mess. So that simplifies down to 69 over 200, but I really wanted to make sure you knew 345 over 1,000. Now, I think that's my time, so I'm going to be done with this and move on to the next part, all right?